So let's take what we've learned about parts of speech tagging and named entity recognition and try it out through a practical lesson. We'll start by importing the packages we need. These are the same ones we've been using throughout the previous lessons, so nothing new here. Once that's done, we can move on to loading our dataset. In this lesson, we'll be working with a dataset of BBC News articles. We'll load it into Python as BBC data using the pandas read CSV method to import the data from a CSV file. Let's take a look at what the data looks like using bbc_data.head. As you can see, we have a column for the index, followed by the title of the article, the publication it comes from, some links, and a short description of the article. We can also run bbcdata.info to get more details about our dataset. This tells us that we have 1,000 entries, in other words, 1,000 rows of data. It also shows that there are no missing values, which means every column is completely filled in. It'll be interesting to see which parts of speech appear in these articles and what kinds of named entities we can identify, things like people, places, or organizations. For now, though, we'll focus only on the titles of the news articles. So let's extract those titles and store them separately. We'll start by creating a new variable called titles and use it to store only the title column from our BBC data frame. Then we'll turn this into another pandas data frame, so it has the same table-like structure we've been working with. To make sure everything worked correctly, we can run titles.head to look at the first few rows. Perfect. We can now see that we have a data frame with just one column containing the titles of the news articles. The next step is to clean up these titles. Since we already covered the text cleaning process in the previous lesson, we'll go through it fairly quickly here. First, we convert the text to lowercase using the .lower function. Next, we remove stop words, the common words like and, the, or is that don't add much meaning to the text. We use a predefined list of English stop words and remove them with a short lambda function that loops through every word and keeps only the ones that aren't in the stop word list. Then we clean up the punctuation. We use the re.sub function from Python's regular expression library to remove symbols such as commas, periods, or question marks. Next, we tokenize the text. In the first line, we take the original title column and apply the word tokenize function to each row. The lambda x part means for every row in our data frame, call it x and then tokenize the title inside it. This creates a new column called tokens raw, which contains lists of all the words in each original title, punctuation and all. In the second line, we tokenize the cleaned version of each title, the one without stop words or punctuation, and store that in a new column called tokens clean. Now, instead of long strings of text, we have lists of individual words that Python can easily analyze. Next comes the lemmatization step. Here we first create a lemmatizer object using WordNet Lemmatizer. Then we apply it to every list of cleaned tokens. The expression inside the square brackets loops through each token, or each word, in the list and replaces it with its base form. The result is a new column called tokens cleaned lemmatized, which stores the final, fully processed versions of our titles, lowercase, cleaned, tokenized, and lemmatized. Let's take a look at it using the head method. Perfect. Now that we've tokenized and lemmatized the titles, we'll combine all those tokens into a single list. Remember, each row in our data frame currently holds a list of words for that specific article title. To analyze all the words together, we need to merge these smaller lists into one. We'll repeat this process for both versions of our text, the raw and the cleaned one. Remember, when we did the tokenization earlier, we created two sets of tokens, one from the original titles before any cleaning, and another from the cleaned and lemmatized titles. So now we'll create two new lists, tokens raw list, which will come from the tokens raw column, and tokens clean list, which will come from the tokens clean lemmatized column. This will give us both the unprocessed and the fully cleaned versions of all the words in our dataset ready for comparison and analysis. Now we're ready to begin with part of speech tagging, or POS tagging for short. The first step is to initialize the spaCy model we'll be using. To do that, we create a variable called NLP and assign it the English language model from spaCy using the spaCy.load function. Let's now create a spaCy document to store the text in the right format. We'll need the join function and indicate empty spaces between the words like this. Once the text is in the right format, as a single string with spaces between words, we process it using our spaCy language model stored in the variable NLP. This step runs the model over the text and analyzes it linguistically. The result stored in spaCy.doc is a spaCy document object that contains the text along with detailed annotations, such as each word's part of speech tag. Next, we'll create a new data frame to store the results of our part of speech tagging. We'll call it POS and set it up as a pandas data frame with two columns, one for the token, that is, each individual word, and one for its POS tag, which shows the grammatical category assigned by spaCy. In other words, this data frame will let us easily see which word belongs to which part of speech, all organized in a simple table format. To achieve this, we'll create a for loop to go through each token in our spaCy document and extract its corresponding part of speech tag. For every token in the spaCy document, we take the actual word stored as token.text and its part of speech tag stored as token.pos_. The FromRecords function creates a one-row data frame from these two pieces of information, and pd.concat then adds that new row to our existing table. By the end of the loop, the table contains two columns, one with each word from the document and one with its corresponding part of speech. The next step is to create a token frequency count. In other words, we want to count how many times each word appears in our document and which part of speech it belongs to. To do this, we create a new data frame called POSDF_counts. We start by using the group by method. We group the data by two columns, the token column, which contains the word itself, and the POS tag column, which contains its part of speech. Next, we use the size method, which counts how many rows fall into each of those groups. In other words, how often each token tag pair occurs. Then we use reset index, because when we grouped the data, pandas automatically placed the grouped columns into the index, and the output is no longer displayed like a regular data frame with normal columns. To fix this, we call reset index, which removes those group labels from the index and turns them back into regular columns. This gives us a clean table again, where token, POS tag, and counts each have their own column. In the parentheses, name equals counts gives a clear name to the new column that holds the counts. Instead of just seeing unlabeled numbers, We now have a proper counts column. Finally, we sort the values so that the most frequent tokens appear at the top. And as you can probably tell, since we ran this on the raw data, the results aren't very clean. The output includes a lot of punctuation marks and stop words. But even though this data set looks a bit messy, we can still find some useful insights by focusing on specific parts of speech. Let's start by looking at the most common nouns in our data set. To do this, we'll take our POS DF counts data frame and filter it so that we only keep the rows where the POS tag equals noun. Then we'll take just the first 10 rows to look at the top results. This gives us a quick view of the most common nouns in our data set. For example, we can see that the word war appears 35 times, making it the most frequent noun. Next, let's do the same for the verbs and take a look at the most common ones in our data set. Here we can see words like says, found, and win. And remember, this dataset comes from news articles, so it makes sense that we see action-oriented words like these. Even from this simple analysis, we can already get a quick overview of what's being talked about and the kinds of events or actions that appear most often in the news. We can also repeat this process for adjectives to see which descriptive words appear most often. In this case, we can see words like new, Russian, and final appearing frequently. These adjectives give us a sense of how the articles describe people, places, or events within the news dataset. Next, we'll move on to named entity recognition, but feel free to also pause this video and try doing some POS tagging on the cleaned up tokens and compare the difference between the two. Now let's move on to named entity recognition, or NER. The process is very similar to what we did for part of speech tagging. First, we create a new data frame called NERDF, which will hold each token and its associated named entity tag. Things like person, organization, or GPE for geopolitical entity. We initialize it with two columns, one for the token and one for the NER tag. Then we set up a for loop that goes through every entity in our spacey document using spaceydoc.ents. Inside the loop, we use a small condition. The function pd.isNA checks if a value is missing. Here it's checking whether the token's label exists. The phrase is false simply means we only continue if the value is not missing. So together, this line says, if the token has a valid label, then process it. When that condition is true, we take the token text, which is the word itself, and the token label underscore, which gives us the human-readable version of the named entity tag. We then use from records again to create a one-row data frame from this information and concat it to our main NER data frame. By the end, NERDF contains a clear list of all the named entities that Spacey found in the text. Let's check that everything has worked correctly by using the head method to view the first few rows of our new data frame. Great, we can see that several tokens have been extracted successfully, including names and places. This confirms that our named entity recognition step is working as expected and is correctly identifying key entities in the text. Next, let's take a look at the most common named entities that appear in our dataset. We'll create a new data frame called NERDF counts. Just like we did earlier for the parts of speech, we'll use the group by function to group our data by two columns, the token and the NER tag. Then we'll take the size of each group to count how many times each entity appears, reset the index to turn it back into a regular table, and sort the values so the most frequent ones appear at the top. When we look at the results, we can see that Ukraine is the most commonly mentioned named entity in this dataset. Even with just this simple analysis, we're already gaining insight into the main topics and locations discussed in these BBC News articles. In this lesson, we explored how to use part-of-speech tagging and named entity recognition to gain deeper insight into our text data. These techniques help us understand what kinds of words appear in our dataset, what they represent, and how they relate to the topics being discussed. Now that we have a better grasp of the structure and content of our data, we're ready to move on to the next section, where we'll explore the exciting topic of sentiment analysis.